Hi, this is Mrs. Sebastian, and we're going to be looking at Unit 1, Geometry, Lesson 10, which is the unit test. If the measure of angle 3 is 60, what is the measure of angle 6? So if you look, I'm going to trace the two lines that create angle 6. It also creates angle 3. These are called vertical angles. And vertical angles are always equal. So if angle 3 is 60, then angle 6 is also 60 degrees. So vertical angles are always equal. Okay, so we've talked about angle 6 was 60 degrees. We need to figure out angle 1. Okay, that's here. Notice it does form a right angle with angle 6. So angle 6 plus angle 1 gives us 90 degrees. Well, we know that angle 6 is 60 degrees. We don't know angle 1. So we're going to add the opposite. So minus 60. 60 minus 60 goes away, and you're just left with angle 1 because those form that zero pair. And 90 minus 60 is 30. So angle 1 is 30 degrees. Name a pair of same side exterior angles. Well, when you're thinking of exterior, that means outside the parallel line. So here's a parallel line, and here's a parallel line. Okay, so outside of those, that means these are not included. The same side would be angle 1 and angle 7 because it's on the left side of that line, that transversal. And then on the other side, you have angle 2 and angle 8. Same side of the line, exterior, which means outside those parallel lines. Okay, if the measure of angle 5 is 36 degrees, then what is the measure of angle 1? So I'm going to start by showing you the vertical angles. So if I've got angle 1, a vertical angle with angle 1 is angle 4 because they're made from the same two lines directly across from each other. Okay? Then I know that the corresponding angle to number 1, notice number 1 is in the top left of that top parallel line, top left. So if I look at the bottom parallel line, the top left is 5. And 8 is a vertical angle with that. So all the blue are equal there. So now I'm going to change to orange. Okay, so angle 2 and angle 3 are a are vertical angles, and angle 6 and angle 7 are vertical angles. Angle 2 and angle 6 are corresponding. Okay, so now I can look at the problem they give me. Angle 5, which is blue, the measure of angle 5 is 36 degrees. So the measure of angle 1, which is a corresponding angle, is also 36 degrees. The way you would find the orange circled numbers is, remember, they are supplementary. So if I was looking for angle 6, I would say 180 minus angle 5, which is 36, and I would get 144. So the orange ones, or 2, 3, 6, and 7, are 144 degrees. Angle EFD, that's this one, is congruent to which one? Well, that one had 3 lines, so it's going to be equal to this one with 3 lines. So that would be A, C, B. The vertex always has to be in the middle. So A, C, B. They could also name it as going backwards. B, the vertex is in the middle, and A. So either way would be correct there. Side EF is congruent to which side? So this side, it has 3 lines, so we look for 3 lines on the other. There it is. That is BC. Could also be named CB. Translate triangle ABC 2 units down and 3 units left. Okay, so I'm just going to start with point A here. So 2 units down, 1, 2, and 3 units left. 1, 2, 3. So A prime, when you move one, if you move a triangle, translate, reflect, or rotate, it is A prime. So that would be at -1, -5. So that would be A prime. Then C, we're going to move down 2, 1, 2, and move 3 units to the left, 1, 2, 3. So it would be at 1, -1. That would be C prime. Okay, and then B, we're going to move down 2, 1, 2, and left 1, 2, 3. So that would be at -2, 1. Another way you could do this, okay, another way you could do this is you could say, okay, down is my Y value and left is my X value. So I can pick the coordinates. You've got A as -2, 1. Okay, you can subtract 2 from the Y and subtract 3 from the X. Okay, and you do get -5, -1. You can continue the same process for B and C. Okay, which is an appropriate classification for a triangle? You've got scalene, isosceles, equilateral, right, acute, obtuse. So you can have any combination of these. So right scalene, right isosceles, acute scalene, acute isosceles, acute equilateral, obtuse scalene, and obtuse isosceles. The only one that can pair with equilateral is acute. Right and obtuse cannot pair with equilateral. Classify the triangle by side length and angle measurement. Okay, so this one, I see a square in the corner. So that means that this is a right triangle. Now I need to look at the sides. I see that this side and this side are equal, which means I have two sides that are the same. Isosceles, I like to call iso 2. That's how you spell it. Isosceles. Name the quadrilateral with exactly two pairs of parallel sides. So this thing could look like this, as long as these are parallel. It could also, sorry, that's supposed to be straight. Look like this. So a quadrilateral with exactly two pairs of parallel sides can be both a rectangle and a parallelogram. But a rectangle is a parallelogram. So exactly two parallel sides is a parallelogram. What is the sum of the interior angles of a pentagon? So when you are looking at the number of sides of a pentagon, that is 5. So you're going to plug it into the formula for the sum of the interior angles, which is 180 times the difference of n minus 2. The n is the number of sides. So here it would be 5 minus 2. So 5 minus 2 is 3. 180 times 3 is 540 degrees. So the sum of the interior angles is 540 degrees. What is the value of the missing angle? Well, in our last one, we used 180 times n minus 2. This is a pentagon, so it does have 5 sides. 5 minus 2 is 3, and 3 times 180 is 540. So I am going to subtract 540 minus each of these angles, 68, 121, 103, and 85. And that will give me what I have left for my last angle. So 180, sorry, not 180, 540, 540 minus 68 minus 121 minus 103 minus 85 leaves me with that angle being 163. What is the value of the missing angle? So this one, there are 6 sides. So I'm going to say 180 times n minus 2. I'm going to replace the n with the number of sides, which is 6. And 180 times 4 gives me 720. So I do see that these squares in the corner are 90 degrees. So I'm going to say 720 minus 140 minus 150 minus 90 minus 90 minus 130. So 720 minus 140 minus 150. leaves us with 120 degrees. Okay, what is the area of a triangle? Well, the area of a triangle, the area equals 1/2 the base times the height. So the base is the bottom. Okay, the longest side. So that's 14. And the height is always perpendicular to the base. That means it forms a right angle. So that's going to be 5. So 1/2 times 14 gives me 7. 7 times 5 gives me 35. And this would be units squared. Okay, units in area are always squared because you're multiplying one side length times another. What is the area of the parallelogram? Well, that is just base times height. Well, they only give you 2 here. So you're going to say 8 times 15, or 15 times 8. Does not matter which order you do. Okay, so when you multiply together, you do get 120. And remember, we are dealing with area, so that is always units squared. What is the area of a trapezoid? So the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So what that means is 1/2 times this base plus this base. You're finding the average length, so you're adding them together and dividing by 2. Okay, so we're going to add those together. So 7.2 plus 4.4 is 11.6. You're going to multiply that by 1/2 and get 5.8. And then multiply that by 6.1. And you do get 35 and 3800ths. And remember, that is units squared. In this one, we're using inches. So it's inches squared. Identify a sequence of transformations that maps triangle ABC onto triangle A prime prime B prime prime C prime prime in the image below. So the first thing that I notice is that we're going to have 2 transformations because there's 2 primes here. Then I notice that the red triangle, which is our image after the 2 moves are made, is a lot smaller than the big blue triangle that we started out with. So I notice that this one from 0 is 1.5 units. But I notice that this one is 3 units. So what can I multiply 3 by to get 1.5? Well, I could multiply by 1/2 or divide by 2. Okay, so it'd be a dilation of 1/2. So the first thing I'm going to do is I'm going to erase what I put on here. So that we can move this around. Okay, and we're going to go over 1.5 and put our A prime here. Sorry, B prime. B prime. And then I'm going to do the same over here. I'm going to multiply that by 1/2. And then C prime is at 5. So now it's going to be at 2.5. Oh, C prime. Okay, not the prettiest picture, but you get the idea. Okay, And now what does it do? It goes from 2.5 or 0, 2.5 to 2.5, 0. That's going to be a rotation this direction, which is counterclockwise. It's the opposite of the way of a clock. And it only moves one quadrant. So counterclockwise, 90 degrees. And that's it. Write a sequence of transformations that maps quadrilateral ABCD onto quadrilateral A prime prime B prime prime C prime prime in the picture below. Okay, so I see this side here matches this side here. So somehow we have to get BC to the bottom. Okay, so I'm thinking we're going to flip it over this. So let's flip that. 4, 1 would become 4, negative 1. That's D prime. A is at 2, 4, so that's going to be at 2, negative 4. Let's see, B is at 4, 5, so that'd be 4, negative 5. And then C is at 5, 4. 5, 4, so 5, negative 4. So now I'll just connect the dots. So now I've got the shape looking the same. Now I need to scoot it over. So far we've reflected. Sorry, cannot spell today. Let's try that again. Over the X. Okay, and then we're going to move it to the left. 1, 2, 3, 4 spots. So we're going to X minus 4, Y. Okay, so if you wanted to write it as a transformation, you could do that just by saying X minus 4 and then negative Y.